Welcome to Module 8 of our robotics programming series with Raspberry Pi Pico. In this module, we're diving into one of the most exciting parts of building a robot, real-time manual control using a joystick. By the end of this lesson, you'll be able to use a joystick to control the base rotation of your robotic arms smoothly and intuitively. Let's get started. First, let's understand how the joystick we're using works. We're using the HW504 joystick module. It's a neat little device that has two potentiometers, one for the x-axis and one for the y-axis, and also a presseable button on top. You move the joystick, these potentiometers change their voltage output depending on the direction and distance of movement. The joystick center gives you a mid-level voltage, around 1.65 volts if you're using 3.3 V input. We'll start by using only the x-axis for controlling the base, and we'll also connect the press button to detect when it's pressed. Let's wire this up to the Raspberry Pi Pico. VCC to 3.3 V. Ground to ground. VRX to GP26, this is our analog input pin. SW to GP15, this is a digital input for the button. VRE won't be used in this module yet. Once it's connected, we can start reading values from it. Now, we'll write a simple script to read the analog values from the joystick and print them to the console. The joystick's VRX pin is connected to a potentiometer inside. As you move the stick left or right, the voltage at this pin changes. This voltage is read by the ADC, analog to digital converter, on the Raspberry Pi Pico. The ADC takes the analog voltage from 0 to 3.3 V and converts it into a digital value between 0 and 65535. That's because the Pico uses a 16-bit resolution by default with the ADC.read_U16 function. So when the joystick is centered, you'll typically get a value around 32767. Push it left and the value drops toward 0. Push it right and the value increases towards 65535. We'll also read the button using a digital input with an internal pull-up resistor. Now let's set up the base servo motor, which will be controlled by the joystick's x-axis. This setup should look familiar. It's the same process we used in the previous module to control servo motors. We'll start by creating a PWM object for the servo and setting the frequency to 50 Hz. Which is the standard for most hobby servos. In Module 7, we defined a helper function called angle_to_duty to convert an angle between 0 and 180 degrees to a PWM duty cycle. We'll use that again here. We also defined a move_base function that takes an angle and sends the correct duty signal to the servo. Let's reuse it to keep things modular and clear. With this setup, our base servo is ready to rotate based on joystick input. In the next step, we'll read analog values from the joystick and map them to servo angles. Before we start moving the servo, let's talk about the dead zone. The dead zone is an area around the center of the joystick where we ignore small movements. This helps avoid jittering caused by slight inaccuracies or hardware noise. We define it as a range of values, say, plus or minus 2000, around the center value, which is 32,767. Now let's combine everything into a real-time control loop. We continuously read the joystick value, check if it's outside the dead zone, and update the servo angle. If the joystick button is pressed, we can also trigger a message or future feature. Up until now, we've been directly sending the new angle to the base servo, which causes it to jump immediately to that new position. While this works, it doesn't feel very natural, especially when using a joystick. So for this mini challenge, let's make the base rotation smoother by reusing a function from Module 7 called sweep_to_angle. This function slowly moves the servo from its current angle to a target angle in small steps, adding a short delay after each small movement. This creates the effect of smooth motion instead of a sudden jump. We'll now apply this logic to our joystick-controlled base rotation. And that brings us to the end of Module 8. In this lesson, you learned how to control a servo motor in real time using an analog joystick. a big step toward more interactive robot control. You now understand how the joystick hardware works, with 2 potentiometers and a button. How to read analog values from the Pico using ADC. How to translate those values into servo movement. And how to use a dead zone to avoid noisy or jittery control. These concepts form the core of teleoperation, or manual robot control, and are essential for both hobbyists and future robotics engineers. In the next module, we'll expand control to multiple servos, explore mode switching, and use the joystick button more effectively for advanced interaction. If you enjoyed this lesson, don't forget to subscribe to the Botronix Labs YouTube channel for more robotics tutorials and upcoming projects. Also, leave a comment if you have any questions or suggestions. I always love hearing from you. Thanks for watching, and I'll see you in Module 9.